What is the area of the inscribed blue triangle?
Line constructions, Pythagoras' theorem, interior angle of regular hexagon, equilateral triangle properties and Viviani's theorem are used to solve this question.
Label points B, C, and D. Join line BD. Since it is a regular hexagon, its interior angle equals 6 minus 2 times 180 degrees, all divided by 6, which equals to 120 degrees. This implies that angle BCD equals 120 degrees. Consider triangle BCD. Using cosine rule, the square of line BD equals 2 times the product of the square of line BC and 1 minus cosine 120 degrees, which equals to 3 times 25, as shown on the screen. Take the square root of the equation. Line BD equals 3 times 25, which equals to 5 times the square root of 3. We call it equation 1. Let the radius of the congruent circle BR with center O. Label points E, F, and G. Join line OE. Let E, F be equals X. From triangle FOE are divided by X equals tan 60 degrees, which equals to the square root of 3. Cross multiply. This implies that X equals are divided by the square root of 3. We call it equation 2. Hence, line G equals X plus 2 times R plus X equals 5. Since line G equals line BC, which equals to line CD, it is because regular polygon side lengths are equal. Substitute value of X from equation 2. Line G equals are divided by the square root of 3 plus 2 times R plus are divided by the square root of 3, which equals to 5. This implies that R times, in bracket, 2 divided by the square root of 3 plus 2 equals 5. Simplify and cross multiply. R equals 5 times, in bracket, 3 minus the square root of 3, all divided by 4. After simplification of values, we call it equation 3. Label points T, P, K, and J. Join line T, K, and line C, G, where T, P equals K, P, which equals half of T, K. Also, K, P equals K, J plus J, P, which equals half of T, K. Also, from equation 1, line T, K equals line B, D, which equals to 5 times the square root of 3. This is because opposite side lengths of a rectangle are equal. It follows that line KP equals the sum of line KJ and line JP, which equals half of line TK. This implies that half of 5 times the square root of 3 equals 2 times R plus line JP. Hence, line JP equals half of 5 times the square root of 3 minus 2 times R. Substitute equation 4. We have that line JP equals half of 5 times the square root of 3 minus 1/4 of 2 times, in bracket, 5 times 3 minus 5 times the square root of 3, which equals to 5 times the square root of 3 minus half of 15, as shown on the screen. We call it equation 5. Let line JP be equals to y. Notice that similar lines can be constructed from other two side lengths of the equilateral triangle as shown in the figure, each having perpendicular line length of y to the side of the triangle. If h is the height of the triangle, by Viviani's theorem, the sum of y and y plus y equals the height, h of the triangle. This theorem states that for any interior point in an equilateral triangle, the sum of the perpendicular distances to the three sides is constant and equal to the triangle's altitude. It implies that 3 times y equals h, which equals to 3 times 5 times the square root of 3 minus half of 15. That is, h equals half of, in bracket, 15 times 2, multiply by the square root of 3 minus 3. Consider the inscribed blue equilateral triangle shown below. Let its side length be w. By Pythagoras' theorem, the square of w equals the sum of the square of h and the square of w divided by 4. It follows that the square of h equals the square of w minus 1/4 of the square of w, which equals the square of half of 15 times 2 multiplied by the square root of 3 minus 3. It signifies that 3 times the square of w divided by 4 equals 1/4 of 4725 minus 2700 times the square root of 3. Cross multiply. We have that 3 times the square of w equals 4725 minus 2700 times the square root of 3. The square of w equals 4725 minus 2700 times the square root of 3, all divided by 3. Hence, the square of w equals 1575 minus 900 times the square root of 3. Therefore, area of the equilateral triangle equals half of the square of w times sine 60 degrees, which equals to 225, in bracket, 7 times the square root of 3 minus 12, all divided by 4, in square units, or 6.995 in square units to 3 decimal places.